Okay, today we're going to be looking at frequency versus period, and then we're also going to be looking at how to calculate wave speed. So when you're looking at frequency versus period, frequency is going to be how rapidly vibrations occur, or you can say the number of wavelengths to pass a certain point in a given time. Okay, so when you're saying for frequency, you're saying how often they're coming. If it's something very frequent, it's coming very often. If it's something that's less frequent, it's not happening as often. When you're looking at frequency, the symbol is going to be an italicized letter F, which we're just going to make it a lowercase f. And its SI units is going to be hertz, which is going to be Hz. Okay, again, this is after a last name for a scientist who researched and studied about waves. Also, they gave them recognition, just like Newton's gets recognition. Now, when you're looking at period, this is going to be the time required for one full wavelength to pass a certain point. The symbol is going to be an italicized capital T, so we're just going to put a capital T, and its SI units is going to be seconds, because you're looking at a time frame, so it's going to be seconds. So when you're looking at doing the calculations for your frequency versus your time, or your period, it's not going to be very difficult to do, because you're going to be looking at a very simple equation, because you're looking at how long or how much time is required for one full wavelength. So you're going to be looking at it, focusing at that number 1 there. So as you're looking at your frequency period, I already wrote it on the sheet here. Okay, kind of got a little ahead of the game there. So frequency period, you're going to take your frequency is equal to the number 1 divided by your period. Period is equal to the number 1 divided by your wavelength. Okay, make sure you know this is a number 1 when you write that. So make sure when you're writing, you know that's not a lowercase l or something else. So make sure that you're paying attention to that. Okay, now when you are looking at this, F is going to be your frequency, and that's in hertz. Period is going to be in seconds. So again, that italicized T is going to be your period. The italicized lowercase f is going to be your frequency. So go ahead, make sure you write that onto your formula sheets, and then make sure you have a calculator, because we're going to need a calculator in order to solve for these problems. Okay, so now we're going to do some examples, and then you're going to complete the rest of them on your own, but you're going to see how simple they are. So number 1 says every 8 seconds a pendulum completes 1 cycle. What is the period and frequency of this pendulum? So we need to figure out these two numbers, period and frequency. Well, it gave us 8 seconds. So 8 seconds is going to be our period, because that's our time frame. So we need to solve for frequency. So 1 divided by period. So 1 divided by 8 would give you 0.125 hertz for your answer. Okay, that's all you have to do. That's as simple as it's going to be there. Okay, number 2. We're looking for frequency and period. So number 2 says the period of an oscillator is 1 minute. What is the frequency of the oscillator in hertz? Alright, so we know our period is 1 minute, and we're solving for frequency. But before we begin, we have to make sure we watch our unit here. We have 1 minute. We need to make sure it's in seconds. So we know how many seconds are in a minute. 60 seconds. So we're going to take 1 divided by 60, because we have to do it in seconds. So 1 divided by 60 would give you 0.0, we'll say 2 hertz. Alright, number 3. Number 3 states, a Ferris wheel spins 5 times in 10 minutes. Calculate the frequency and period of this Ferris wheel. Alright, so it goes around 5 times in 10 minutes. How many times do we care about it going around? Just 1 time. We only care about 1 time, not 5 times. We only care about 1 time. So we have to say, how long does it take to go around 1 time? Well, you take 10 divided by 5, and that tells you that it goes around 2 minutes each time. Okay, so our period is going to be 2 minutes, because each time it goes around, it takes 2 minutes for it to go around. So our period is going to be 2 minutes, but we have to change it into seconds. So when you're looking at this, 2 minutes, you're going to be looking at turning into seconds. So you're going to take 2 times 60 to turn into seconds. So you're going to get 120 seconds. So frequency equals 1 divided by period. So 1 divided by 120 would give you 0.008 hertz. Okay, that's as simple as you can make it. You just take 1 divided by a number. You just have to make sure your time frame is in seconds, and you have to make sure that you're only looking at it going around 1 time. Alright, you just finished up your frequency period problems. All 8 of them should be in your notebooks. I think it was 8. Nope, 7, just kidding. All 7 of them should be in your notebooks. So make sure you have them in there. Now, we're going to be looking at the last equation of the trimester here, which is going to be wave speed. So you're going to say how fast these waves are moving. Now, when you're looking at wave speed, it's going to depend on mediums. So it depends on the medium of how fast it's going to travel. Because if it's going in a solid versus a liquid, it's going to move faster. If it's in the air versus a liquid, it's going to move faster in the liquid, just because of how the proximity are to the particles. So if you're looking at sound waves, they're going to travel 3 to 4 times faster in water than in air. Okay? That's why when you're talking to somebody underneath the water, you have to slow down how fast you are talking so that they can hear it, because of how fast those sound waves are traveling. If you're looking at them traveling in a solid, so like rocks of some kind, they're going to travel 15 to 20 times faster. You could say in solids, because it could be rocks or it could be mud there. Just because you're looking at there being in close proximity to one another, they're going to move faster. So it's based on those particles. The closer the particles are to one another, the faster the wave is going to move. So we're going to calculate wave speed very similar to what we calculated speed before. So wave speed is equal to your speed, which is still v, being equal to your frequency times your wavelength. Okay, your wavelength is what we call lambda. Lambda is an upside down looking Y thing. It's a Greek symbol. So you have to make something that looks like a Greek symbol of a lambda. Alright, so you could just do kind of an upside down Y there. Frequency equals speed divided by wavelength, and wavelength equals speed divided by frequency. So V is still your speed, which is still meters per second. F is your frequency, and that's in hertz that we just talked about this last time. And your lambda is your wavelength, which, since it's a distance, because it goes crest to crest or trough to trough, is going to be in meters. So you looked at the wavelength in the notes when we went over the parts of the wave there. Okay? So, you're going to solve it like we've been doing the other problems here, especially when you looked at the speed problems. You have the very same setup there. Okay, so when you're looking at this, that's what you're going to be doing. Okay, so as I was saying, the speed is very similar to how you solve for speed and velocity to how you're solving for wave speed. Alright, these last two boxes aren't going to get filled in, so leave them blank. We're not going to have anything to go with those. So we're going to be looking at doing your practice problems here. So you're going to do these in your notebooks just like normal. So we look at 1. We're going to list V, frequency, and lambda. So it tells us a wave of water has a frequency of 500 hertz and a wavelength of 3 meters. What's the speed of the wave? So hertz is our frequency, so it's 500. Our wavelength is 3. So our speed is going to be frequency times wavelength. So 500 times 3. So you're going to get 1500 meters per second. Okay, number 2. We'll start variables again. It says the lowest pitch sounds humans can hear as a frequency of 20 hertz. What is the wavelength of these sounds if their speed is 340 meters? So it told us our frequency is 20 hertz. It told us they are moving 340 meters per second. So we're going to be solving for their wavelength. So as we see, wavelength is going to be, let me get up there. Wavelength is going to be your speed divided by your frequency. So your speed divided by frequency. 340 divided by 20. 340 divided by 20 would give us 17 meters for our answer. Alright, and then number 3 here. Number 3, the highest pitched sound humans can hear has a wavelength of 0.017 meters in the air. What is the frequency of these sound waves if their speed is 340 meters per second? So it told us our wavelength was 0.017 and told us they're still moving at 340 meters per second. So we're solving for frequency. So frequency equals speed divided by wavelength. So speed divided by wavelength, 340 divided by 0.017 would give you 20,000 hertz for your answer. Alright, so as you see, they're very similar to how we solved for speed and velocity back at the very beginning of the trimester, so they shouldn't be difficult to do. Alright, so you're going to continue on with the rest of the worksheet in your notebooks there. So you're going to have 12 more of these. You should have already finished the frequency period problems in your notebook, so you should have 1 through 7 done of those. Once you have both of them done in your notebooks, then you are done with the speed problems and the frequency period problems.